Hi everyone, my name is Peter Gadiwango. Welcome to my YouTube tutorial. In this section, you're going to be dealing with Organic Chemistry 1, and we are continuing with covalent bonding. And our objectives today are definition of a covalent bond, types of covalent bonds, and then lastly, but not least, we shall look at dipole moment. And if time allows, we shall do some sample questions about this topic. So to begin with a covalent bond, we know from genochemistry that a covalent bond involves sharing of electrons between two elements. So it's still the same definition that we also use in organic chemistry, but in this time, when we go to the types of covalent bonds, we have what we call a polar covalent bond and a non-polar covalent bond. So polar covalent bonds are, for example, if I give an example of water, we say that water is a polar molecule. Reason being that the oxygen in this in water is bonded to two hydrogens, and we said in one of my genochemistry 1 lecture, I talked about what we call electronegativity. Electronegativity is the ability of an atom or an element, basically an atom, to pull electrons towards itself. So from group 5 up to group 7, members have a very high electronegativity potential. So therefore, when we say that oxygen is among those groups, which is in group 6, so oxygen has a higher electronegativity compared to hydrogen. So therefore, oxygen will pull the bonding electrons towards itself. So these electrons are more on the oxygen side than the hydrogen side. So this creates what we call a partial negative on the oxygen, since most of the electrons are towards the oxygen, and this creates a partial positives on the hydrogen. Now this makes the molecule of water polar. So this is what we call a polar covalent bond, when we have both a partial negative and a partial positive charge on an element, or on a molecule. Another good example, we have nitrogen, ammonia. So since nitrogen is more electronegative than hydrogen, it will pull electrons towards itself. So this gives nitrogen a partial negative and this partial positive. So in the end, we get a polar molecule with a polar covalent bond. Well, as a non-polar covalent bond is one where electrons are shared equally. So a good example of this is when chlorine bonds with chlorine, they both share these two electrons equally. The same applies to oxygen and oxygen, hydrogen and hydrogen, because since these two have the same electronegativity potential, so the pull is going to be equal, so we won't have any partial negatives and partial positives. So non-polar bonds exist between two atoms that are the same, or we can see that in some other molecules such as methane. So methane is a covalent, is a non-polar molecule, because when I draw the structure, so this is the structure of methane. So these hydrogens have the same pull. This hydrogen has the same pull with this and this and this hydrogen. Then in the end, they all cancel out, and you remain with a molecule which is non-polar. So to review, polar molecules always have one electronegative element that pulls electrons towards itself, resulting to formation of partial charges, negative and positive. So that qualifies the atom, the molecule to be a polar. Then for the non-polar is when we have atoms of the same element, they will have the same equal pull, and the resultant dipole moment will be 0. And then for another example is in methane, where we've seen that the hydrogens have the same pulling effect, and the resultant force is going to be 0, so making the molecule non-polar. So since that we've seen the two types of covalent bonds, polar and non-polar. So let us continue with the dipole moment. Now that you've understood covalent bonding, polar and non-polar, a dipole moment is defined as, or is like an equation that says that the dipole moment is equal to the size of a charge times the distance between the two charges. So a dipole moment of a bond is equal to the size of the charge times the distance between the two charges. So what does this mean? So from the word di means two, right? And then pole means either positive or negative. So it means that you have two elements, like for example hydrogen, let me say hydrogen and chlorine. So these two elements have two dipolar. Hydrogen is partially positive because chlorine is more electronegative. It pulls the electrons towards itself. So now these two are polar, right? And what we mean by dipolar moment, it means that how far are they from each other. So the farther they are from each other in terms of electronegativity, the greater the what? The dipole moment. So here I have some of the examples of dipole moments of elements, carbon and hydrogen, specifically with other elements. So with dipole moment, we would like to see the effect of electronegativity on these atoms of these elements. So when we see carbon and hydrogen, we see that hydrogen is atomic number 1 and carbon is atomic number 4. So now carbon is more electronegative than hydrogen. So the distance between these two is a bit not so huge, because electronegativity goes on increasing as we go towards the group 6, 5, 6, 7. So carbon and hydrogen have a pretty close dipole moment, but carbon with carbon, the dipole moment is 0 because they both have the same electronegativity, so it cancels out and you get 0. Then carbon with nitrogen, we see that carbon is next to nitrogen in the periodic table. Carbon is group 4, nitrogen is group 5. So that's the like only difference in one group is just a 0.2 dipole moment. So these two almost have a similar electronegativity, it's almost close. So that's why the resultant dipole moment is 0.2. Then carbon with oxygen, we see that from group 4 to group 6, there's at least a bigger gap. And so it means that you will find the electrons more towards the oxygen than the carbon. Whereas we here, still the same case, but they kind of share it equally. Here the dipole is 0. Here you find the electrons towards carbon than hydrogen because carbon is more electronegative. Then lastly, for carbon and fluorine, we say that fluorine, the dipole moment is very high. So fluorine is the most electronegative element. So if it's more electronegative, meaning that these electrons are going to be found towards the fluorine. So remember we said that dipole moment is the size of the charge times the distance between. So if carbon and fluorine are further apart, so that's going to increase, it's going to increase the dipole moment. So to refer to hydrogen, still the same case. Hydrogen is group atom number 1, nitrogen is number 5. So we see that very big gap between electronegativity. So the electrons will bend towards the nitrogen. The same applies to oxygen, fluorine, chlorine, bromine, and iodine. But you see that there's a trend when you check on the halogens. Since fluorine is the more electronegative, it has the highest dipole moment on both hydrogen and carbon. So meaning that fluorine is so electronegative in that the electrons are pulled towards itself. Then we see that fluorine still has a higher dipole moment than chlorine, bromine, and iodine in that order. So in what you have to take from this is that fluorine is the most electronegative element in the periodic table. So there are very many questions that they usually ask in organic chemistry, and one of them is they can ask you which of the following has the smallest or has the largest dipole moment. So they give you this. So if they give you a number like this and they tell you which of the following has the largest dipole moment, you have to refer to, or which of this is the most polar. So you refer to electronegativity. The more electronegative the atom is, the more it's going to pull electrons towards itself, the more it is electronegative, and the more the dipole moment. So when we look at this, we shall first select fluorine because it has the what? It's more electronegative than all of these elements. So this will be number 1. That will be our answer. So if they will tell you to arrange them in the order, then we will follow the periodic table. Fluorine is the most electronegative in the halogens, followed by chlorine. So chlorine will be number 2. Bromine will be number 3. Now, since hydrogen is non-electronegative, or it has a very small electronegativity, it will be the last in this example. Then another question that they can bring will still be like, which of the following, or explain why HCl has a smaller dipole moment compared to HF. Has a smaller dipole moment compared to HF, but HCl is more acidic than HF. So you answer, if they ask you for why does HCl has a smaller dipole moment compared to HF, is because fluorine is more electronegative than chlorine. Then they'll ask you, why is HCl more acidic than HF? Still the answer is rotating around what? Electronegativity. So you know that if an element is so electronegative, it will try to cling. Fluorine it forms an unstable ion of F minus, whereas chlorine forms a stable ion which is Cl minus. So when chlorine loses this electron, it's more stable than fluorine losing an electron. So those are some of the questions that they can bring for you in this chapter. So thank you for watching this video. Tune in next time for my next video. Thank you.